The first one is writing a recursive formula for me. Here's your sequence. 5, -2, -9. You have to establish what the pattern is first before we write our recursive formula. Anytime it does ask for recursive formula, we're looking for 2 parts, if you remember. 2 parts. First part's the easiest. What is it? What am I looking for? First term. First term. How do I write that in notation? I can't write first term equals. I don't want to write out the words first and term. How do I write it? A1, or I can do F1 in parentheses, remember? Equals 5. So that's got to be your first part. Tell me where you're starting. And then the second part is, what's the rule here using the previous term? All right, so I start out, I always just go A subscript N. Any term can be found. If I start with that, what's my previous then? How do I write the previous if this is the term I'm on? A with the subscript of what? N minus 1. And then now you guys tell me, what do I need to do to the previous term to get to the next here? Subtract 7. So I say, make it clearly out of the sub. Don't put it down here. Make sure it's clearly out of there. Minus 7. Questions there? Going. We're all set? Sure? Write in your own. And then now is, what if I give you one and you got to find a couple values? All right, first term's 1. Now look, we just got to be comfortable with this. I started with AN on mine. It's starting with AN plus 1. Doesn't matter. If I start with that, this is still my what here? A sub N. That's still my what? Ooh. If I'm on N plus 1, N would be the term before, previous. I'm just writing it a little bit differently than I did up here. They mean the same exact things. Can I find the third term? Ready? Right now. No, right? Good. I can't. I need to find what term first? That's how this all works, this recursive stuff. You got to find the previous before you find the next. All right, help me. How do I find the second term? Take the previous, which was 1, do what with it? Square it and, all right. So I end up with 3. Now you can find the third term. How? Keep talking with me. 3 squared plus 2, 11. Questions there? This is a part of the quiz on Thursday, recursive formulas. Yep.
So why'd you, do you just ignore the first part, the AN plus 1, when you're doing the equation?
No, this means, right here, this means that's any given term. So what this is saying, go ahead, pick any term in the sequence. 6 term. So what this is saying is, oh, you want to find the A6? You better find A5, square it, and add 2. That's what that's saying. All right. Up here, I wrote it as AN. But look, when I pair these 2 together, that makes that the previous. When I pair these 2 together, that makes that one the previous. Okay? Other comments or concerns before we move on today to a special type of sequence? Everyone has this sheet. You got it as you came in. Anybody need it? Please hold on to this for the remainder of the unit and year. Everyone see what you got in front of you? I'm going to give this to you on the quiz on Thursday. All right, and you'll have, this is your Regents exam too, what will be given on the Regents exam. There's a couple things on here that I believe 1, 2, 3 things on here that we're going to use this unit. And you don't need to memorize, so I'll be bringing one of those up here in a couple minutes. So anything we need to touch upon, recursive, before I move on? Anything? We're good? I don't think we need to do this one anymore. Okay, let me move on then with today's stuff. A new type of sequence. You know what stinks about this recursive stuff? Like, say I wanted to find the 50th term. What are we going to have to do to get there? Oh, find all 49, right? So I can get to the 49th and do something with it? That stinks. There should be something there that gets me to the 50th right away. And there is. And that's what I'm going to show you right now. Instead of a recursive formula, we have what's called an Anybody want to pronounce that bad boy? Yeah, explicit formula. An explicit formula will get you right to the term you want now. Now, you don't need to know anything about the previous term. Take a look. Here's an example of an explicit formula. A subscript n equals 2 to the n. We don't see any minus 1 anymore, do we? Here's why. You want to find the fourth term? Plug in 4 for n. Done. You'll find the fourth term in that sequence right away. Ready? A sub 4. What did I just plug in for n? Everyone see it? I just plugged in 4 equals 2 to the fourth. And now I'll give you the fourth term in this sequence right now. I don't need to know squat about the third term. Don't care. Explicit formula gets me to the term I want right away. So let's go 2 to the fourth. It's not 8. 16. So the fourth term in this sequence is 16. Done. And just a couple more to make sure we got how this works. A sub 6. Sixth term. How do I find it? Just plug in 6. 2 to the 6. One advantage over a recursive is I can go to whatever term I want now. And 2 to the 6th. 64, everybody? Are you understanding what I'm finding here? This is the term. So the fourth term, 16. The sixth term will be 64. How about the 10th term? So now I'm going to plug in A subscript 10 in for n and do 2 to the 10th now. And what do you end up with? 1024 is the 10th term in this sequence. Good job, everybody. Questions on your end? All right, I'll give you about a minute and a half right now to do example 2. Write the first 5 terms of this sequence if I give you this explicit formula. All right? Yes, Molly?
Can I borrow a calculator?
Sure. I think I only have one on me, so 1, 2, 3, 4, and 5. You should not be doing anything with the previous term. All right? Explicit, you plug in the term you want and find it.
Thank you.
Okay, how we doing? You plug in 1, we will get 5. So we got 5, 2, 2. No, we don't have 2. 5, 2. Negative 1. Negative 4 and negative 7. There you go. There's your first 5 terms. All right, we see the difference between explicit versus recursive. Recursive, got to know something about the previous. Explicit, I just plug in the term I want to find. Whatever number I want to find. Questions? Okay, now it's time for a special type of sequence I got to show you. All right, a special type called arithmetic. All right, or some you could call it arithmetic too. That's fine. It doesn't matter. So instead of telling you what it is, I want you to tell me what it is. So up there I have three types of arithmetic sequences, and I want you to tell me what makes a sequence arithmetic based on those three. It's a pattern. Okay, there's patterns involved now. All right, so take a look at sequence number 1. I got 1, 6, 11, and so on. 10, 8, 6, 1, 1/2, 0. There's a pattern there. Why are these considered arithmetic? If you want to take a stab at it, let me know. What's in common about all of them? What's up, Ed?
Well, for each sequence, there's the same amount for each number. So the amount they're going up or down by is never changing. So it's constant.
All right. So does everyone see the first one's going up by what?
5.
5. The second one's going down by?
2.
And the third one's going down by? Okay. Now, I don't like to say down because I don't want to subtract. We're always going to be adding the same thing. All right. So what makes a sequence arithmetic? Add the same number every time. And we're going to put a name to that number we add every time. Okay, we're going to put a name to it. It's called the common difference. That's the number we add every time in an arithmetic sequence. So that's the number added to every term. So let's try this out. Number 1, what am I adding to every term? 5. So watch how I'm going to write this. Common difference, the notation is the lowercase d. So we say d equals 5. That means I'm going up by 5 in that sequence. All right, now watch. Ready? I don't want to say subtract 2. Instead, you add what?
-2.
Okay, so my d value here, your common difference is -2. That's what I'm adding every time. And then finally, number 3, what's my common difference there?
-1/2.
Negative. I'm going down, subtracting 1/2, which means I'm adding -1/2. Arithmetic, adding every time. What I'm adding by, that's called my d value, common difference. Okay, everyone good? Okay. So now what I got to show you is anytime a sequence is arithmetic, I'm going to have you guys write your own explicit formula for it. Okay, what's the pattern here? For number 1, a sub n equals whatever. When I plug in 3, I better get 11 back out. So you guys are going to help me create a formula here where I plug in the number 3 and I get 11 out. I plug in 4, I get 16 out. I plug in 5, I get 21 out. Okay? But you don't have to memorize how to do it, which is the good thing. So here is the explicit formula for an arithmetic sequence. Everyone look on your reference sheet, please, because it's on there. Take that reference sheet I gave you, please. Everyone look on the left-hand column. There's only one arithmetic sequence one, right? Everyone sees it? Okay, that's the formula we're going to use to write an explicit formula. A sub n equals A1 plus n minus 1 times the d value. Anytime we're dealing with an arithmetic sequence, this is the formula we're going to use right off the formula sheet. No need to memorize it. I'll give it to you. Just a reminder, this is any term in the sequence. Any term. Any term. What's A1 for us? I know it's already written down, but we knew it already. What am I plugging in there?
First term.
First term. D value.
Common difference.
That's what we just been. What are you going by? Okay. What are you going by? And the n value is number of terms. And I'll show you what to plug in for that in a second. You ready? Okay, now I'm going to start calling on people. Find the 9th term now of this sequence. Find the 9th term. What did I give you guys? What did I start you out with?
First term in the
First term is 9. And what's the next part I gave you? It says d equals -5, but what's that mean to you? I'm adding -5 every time. But hey, I don't have time for this. Oh, 10. Let's add -5. Let's add -5. And when I get to the 9th one, I'll be all set. No, because you know what I'm going to do on the quiz on Thursday? That won't be the 9th term. That'll be the 60th term. You don't have time for that. Okay, so I want to use this formula now to find the 9th term. All right, we're going to use this formula to find the 9th term. Here we go. What term am I finding? 9. So what am I about to plug in for n? 9. Remember that. A sub 9 equals first term? 10 plus. How many terms am I dealing with? Plus, even if you don't know that, what did I just plug in for n right here? So whatever you plug in for that n, you better plug in for that n. They're the same things. Everyone see that? 9 minus 1. And what's my d value? Okay, time out. What's happening between the d value and this parenthesis? What operation? This is multiplication. It's not -5. It's times -5. Common mistake with the rookies. It's times -5, not -5. The d value gets multiplied. All right, just plug that all in your darn calculator. And I'll ask somebody here in a second, what is the 9th term? Please don't yell it out. Here we go. 2, when you're ready. Jenna, when you're ready. -30, how's that sound, everyone? Looks good? So there's the 9th term, -30. Okay. Any questions from you guys finding the 9th term using this? Ready to move on? Okay, now I don't want the 9th term, I just want a formula to find any term. Okay? Anytime you guys see this, please make a note of this. When you're asked to write for the nth term, that's the same as write me an explicit formula for this. Okay, you're going to write an explicit formula where I plug in a number and that's the term it is. All right, ready for your formula? It's arithmetic, so get the formula off the formula sheet and I'll help you plug it in. A sub n equals A1 plus A minus 1 times D. Let's see how much we can plug in for.
That was n minus 1.
Oh, n minus 1, sorry. I don't know where the A came from. I know, one jab. All right, here we go. Am I asking you to find a certain term? No, this is for any term. This is going to work for any term. So guess what A sub n is going to stay? A sub n. This is how to find any term in this sequence. I take A1, help. -8. I add 2. I'm not plugging in anything, right? N is staying n. That's what it stayed here. I don't know how many terms I have. This is for any number of terms. Minus 1. Now you guys help. D value? Multiply? Oh, multiply this by 2, yes. Yeah. I thought you meant the rule was multiplied by 2. Right, now that right there, what you're looking at would be an acceptable answer. But my expectations are a little bit better. I need you to clean up that right side, please. Clean it up. What do I mean? Somebody help. What do I mean by clean it up? What can I still do here? Thank you. Distribute the 2. I can't distribute the -8. It's being added. I can only distribute the 2 because it's being multiplied. So A subscript n equals -8 plus, go ahead guys, what do you have here? Plus 2n minus 2. I still don't like it.
-2 and -8.
Yep. So my formula is going to be A subscript n equals 2n minus 10. That is how you find any term in this sequence. Tomer, I know you're excited about this. Watch how this works. Everyone plug in 3 right now into the formula for n. Plug in 3. Let me know what you get. Plug in 3 into our formula. What do you get?
-4.
Negative what?
4.
Everyone getting -4? Oh, what was the third term in the sequence?
-4.
That's how it works, right? That's how explicit formula works. You want to find a certain term, you plug in that number and you get it. All right, so this is how to find any term in the sequence you just created using that formula on the formula sheet. N stays N. All right. Questions? Think you could try one on your own?
Mhm.
All right, number 3, go ahead, find the 20th term now. Use your formula. It's arithmetic. Use your formula. Find the 20th term. So I pull this right off the formula sheet. Now I'm finding the 20th term. Make sure you're multiplying that d value, please. Multiply it. Okay, I'm going to ask somebody to help me plug it in now. Plug in some numbers here for me. 1 zip, 1 4. Ava, here you go. A, what term am I finding?
20.
So that's n. First term?
3.
Yep. Plus, what's in for n now?
20.
Good job. 20
-1.
times
7.
7. Good. That's my common difference, going up by 7. Good work, Ava. Good work. And what do we got for the 20th term here?
136.
Should be a nice positive number.
136.
136. Okay. Good work. Anything I can answer here? So what we've done so far with this formula is find any term in the sequence and do a general rule, explicit formula for the sequence. Anything before I work on some other stuff? We're okay? All right, so go ahead, number 4, find it. What are they asking me for in this problem? The 99th term. Yep, here you go. Probably don't want to list those out, huh? Probably would prefer the formula. Find the 99th term of this one. Okay, help me plug it in. Jenna, go ahead. N value.
-8. Oh, no.
Relax.
9.
Thank you. A1
-8.
plus, what's your N value?
99 -1 times 4.
There we go. Should have a positive number here too. What do we have? Positive 384. That would have taken us a while without the formula, right? Okay, anything. We comfortable before I just changed it on you a little bit? I know that's how this class works, right? We get so comfortable. You're like, not bad, not bad. Then I throw it at you and it's like, come on. Now my confidence is down the drain. Shouldn't be. Okay, what am I asking for here?
First term.
First term. So you know what you're solving for now, right? A1. Which means to me, everything else in the formula has got to be filled in, except for A1. Can't touch A1, but everything else should be filled in. Ooh, how? What am I giving you here? Find the first term if,
A5.
what's that mean, A5? I can,
Term.
fifth term is 1.5 and
Click on the differences.
I'm going by 4.5, right? Okay, so let's get the formula out because I want to use the formula. I'm solving for A1. Leave it A1, please, right? I'm solving for it. Which means, oh boy, AN? AN? We'll go back. Let me go back real quick. What was AN represent? That's
Any term.
any term in the sequence. Go back. Do you know any term in the sequence? Darn right, you don't?
You do.
You do.
Fifth term.
What is it? What term do you know?
That's fine.
Fifth term, what is it?
Fine.
It is 1.5. I know, yeah, I know a term in there. It's 1.5. Let's throw it in. Equals first term, right? That's staying A1, or you can put, I don't know, put an X. I don't know, whatever makes you feel happy inside. Plus, all right, here we go. Here's where we got to be careful. N is, again, going back, the number of terms we're dealing with. What did you just plug in the left side? 1.5, which is how many terms? 5. That's 5 terms, isn't it? So a 5 goes there. Not 1.5. You're not talking about 1.5 terms. This is the terms position in the sequence, 5. All right, that's the terms position. Minus 1, and we were told the D value was what? 4.5. Take a look, especially that N value. That's the term number of whatever you plugged in on the left side. Okay, I don't know how comfortable we are solving this. I hope we're comfortable. I don't know, what's 4 times 4.5? 9, 18. So A1 plus 18. What do you want to do next?
Subtract 18.
Move the 18 over by subtracting, absolutely. And that'll give us a first term of negative what?
16.5.
I was gonna, should have a half in there. My big thing here, do we see here how these are related? This right here is the term's position in the sequence. It was the 5th term. Yep. I'm ready.
Actually, that might not even apply, but I was wondering if you could do that for like the other ones too, like instead of putting like actually never mind. That doesn't
Okay.
make sense.
Anybody else? Oh, you wanted a word problem? Sure. How about Big Trev? What a great guy Trev is, huh? He opens up an English language school in Japan. What a great guy. He starts with 26 students, 3 new students every week. How many weeks is he going to have? 101. And I do not have patience or time for 26, 29, 32. When are we going to get to 101? Okay, we don't have patience for that. So let's see if we can use the formula to find it. How many weeks will it take to get to 101? You tell me, what are you confident in filling in right now?
First term.
Alexa?
The 3 for the D.
Okay, so times 3.
And 26 for your A1.
26 for A1. I think we all should be confident in that, right? So that means, all right, I still have what number up there to put in? Okay, think about it. What is 101? That's a term in the sequence, isn't it? That's not how many terms I have. That's a term in the sequence. So what should I plug it in for? If 101 is any term in the sequence. Where do I plug in a term, any term in the sequence?
AN.
AN, 101. And you hit this, look at what you're trying to figure out. By solving for n, you're trying to figure out when do I hit 101? At what term do I hit 101 in the sequence? That's what the n's going to be. So I get 101 equals 26 plus 3n minus 3. Distribute. What do you get there? 3n plus 23. You guys can handle that from there? How many weeks?
26.
Ooh, 26 weeks. Questions on how I use that formula before we get to the last one? Okay, here you go. I don't want to say too much other than what I'm looking for here. So I have these things called arithmetic means. Okay. Basically, think of a sequence. Take a couple numbers out in the middle. I'll give you the beginning and the end. I'm going to take a couple numbers out in the middle. I want you to find those numbers in the middle. That's what an arithmetic sequence is, or an arithmetic means. So I want to find 3 arithmetic means between 2 and 22. So I'm starting with 2. How many numbers are in the middle now? I have 3. 3 arithmetic means. And you know, hey, you already know they're going up by the same amount because it's arithmetic. And then I end it with 22. So what has to be those 3 numbers in between that they go up by the same amount? And well, I'm not into the guess and check business here. You tell me, let's see if we've got anything out of today's class. What value would be huge here? If you're trying to find what I need to go up by, the D value. All right, I need to find the D value. Because then if I find the D value, add it to 2. Keep adding, keep adding. All right, get out your formula, because that's the only thing that has the D value. Okay, so I need to find what I'm adding up every time. What are you confident in plugging in for right away?
2.
2 in for what?
2.
Yep, there's the first term. You guys know any other term in the sequence? Okay, ready? 22. Let's see how much we're made of now. Plus, what you going for n? What's the position of 22 in the sequence? It's the 5th term. So 5 minus 1. And now we're solving for D. So we get 4D. I don't know anybody distributing the D. 5D minus 1D. It's 4D, right? 5 minus 1 is 4. Do the parentheses times D. Next move. Subtract 2. So what do we get? 20 equals 4D. So what's my D value? Okay, 5. So what are you going to do with that 5 now? Okay, so ready? Your first number there after 2, your second term? 7. I'm adding 5 every time. That's why I found it. Next one? 12. Next one? And hey, look at that magic. Do it again, and where do you end up? Okay, we must have did something right. So I just need the D value. Open up your Chromebooks, or you can try out the word problems on the next 2 pages. It's up to you. All right, word problem on the next 2 page on the next page, or get out the Delta Math, get going on the Delta Math assignment. Tomorrow, you'll come in. No teaching tomorrow. No notes. I'm going to put you in groups, and you have your first group assignment tomorrow. I'm going to give you an assignment out of the book that deals with this, what we did today. You and your group are going to work on it. I will come over at the end of the period and randomly choose one person's to grade. Okay, so not one person is just doing all the work and nobody else. Yes.
Are you choosing groups?
I don't know yet how I'm going to do that. Okay, I'll have to figure that out. Okay, we can get going on the bookwork, on the, not the bookwork, excuse me, the 2 word problems or the Delta math assignment, either one.